My favorite data set to talk about is NASA's Faster, Better, Cheaper missions. But let's take a moment here to talk about Mars. There's a saying in the space community that Mars eats spacecraft. Mars is a fiendishly difficult place to go. In fact, the Russians made 19 attempts to get to the red planet. None of them succeeded. In 1976, NASA launched the Viking mission to Mars, which was actually a huge success. They put 2 landers on the red planet, which was humanity's first attempt to ever put a spacecraft on another planet. At the end of this mission, about a couple of years later, how did NASA feel about that? Their assessment was that was awesome, that was great, let's never do it again. It was 20 years before NASA tried to do another mission to the red planet. You see, Viking, while it was successful, was the wrong kind of success. It was so expensive, so complicated, and so difficult that at the end of it, NASA just had nothing left. It's a type of success that created barriers to future attempts. The lesson here is that even when they're successful, these big, expensive, complicated missions can end up costing more than they're worth. 20 years later, NASA eventually did make another attempt to get back to Mars. And in 1997, they launched the Pathfinder mission to Mars. If you've seen the movie The Martian, this is the spacecraft that saved Matt Damon's life. So right there, we know it was worth it. This was humanity's first attempt at putting a rover on another planet. Now, putting a rover on another planet is an order of magnitude harder than a lander. It's the difference between a plant and an animal. Because when we begin moving around, we're faced with a whole new set of challenges, dangers, demands, and questions. But Pathfinder took a very different approach than Viking did. Pathfinder was developed for 1/15th the cost by a team a third of the size and developed in half the time of Viking. It was designed to last for 7 days. They hoped it might last an entire month. It lasted 83 days before the base module lost communications with the Earth. They collected 17,000 images over that time. So how did NASA feel about Pathfinder? Their assessment of that one was, it was awesome, it was great, let's do it again. They went back 3 more times so far, and there's a 4th mission in the works. In 2004, Spirit and Opportunity landed on Mars. They were designed to last for 90 days. Now, Spirit only lasted 6 years before it lost communications in 2010. Opportunity, on the other hand, lasted for 12 years and is still going. Opportunity is still active more than 12 years after it landed on Mars. Now, Viking, as I mentioned before, cost $3.8 billion in 2014 dollars, constant year 2014 dollars. Opportunity was only $400 million. That's about 1/10 the cost of Viking. Fast forward a little bit, Curiosity landed in August of 2012. Its 2-year mission has been extended indefinitely. Now, Curiosity was considerably more expensive than Spirit and Opportunity. It cost $2.5 billion. Now, that's a lot of money, but it's still just 2/3 the cost of Viking. One of the primary missions for Curiosity, was to serve as the basis for the Mars 2020 rover. So Curiosity is setting a foundation for the mission that comes next. The Mars 2020 rover is projected to cost $1.9 billion. Again, a lot of money, but only 75% of the price of Curiosity. So the price for putting rovers on Mars is going down. So there's 3 lessons to consider here when we look at these various Mars missions. First is that projects that fit the FIRE model, these fast, inexpensive, restrained, and elegant missions, tend to outperform their specs. They tend to do more than they were designed to do. They tend to last longer. The second lesson is that small projects can do big science. And the third lesson is that the best kind of success, these incremental building blocks, lead to more attempts and more successes. Whereas the worst kind of success, the Viking model for success, sets up barriers for subsequent efforts and subsequent experiments. So as you move forward on your projects and you think about what you're going to be doing next, take a look at the small, the inexpensive, the fast, the elegant, the streamlined approach, and avoid the Viking model where we're spending a lot of money and a lot of time building really big, complex systems. Again, if you want to go to Mars, you're better off going small.